Welcome to Sunil Maths tutorial. Let us start a new lecture series, Fourier Series, Class 1. The first definition, periodic function. A function f of x, is said to be, a function f of x is said to be periodic function with period t, with period capital T. A function f of x is said to be periodic function with period capital T if it satisfies the condition f of t plus x is equals to f of x for all x belongs to capital R and where t greater than 0. A function f of x is called periodic function if it satisfies this condition f of t plus x is equals to f of x for all x belongs to capital R where t greater than 0. And remember that there is one important condition, and capital T is the smallest value. Capital T is the smallest value of such values. Right. That is what it means. F of x plus t gives us f of x plus 2t is equals to f of x plus 3t, it is equals to, and so on, is equals to f of x. But t is the smallest one. Here, capital T is called period. Capital T is called period of the function. Period of the function f of x. So to understand this definition, let us see one example. Suppose a well-known example, f of x is equals to sin x. Now f of x plus 2 pi, obviously sin of x plus 2 pi, you get sin x. F of x plus 4 pi, you get sin of x plus 4 pi, which is equals to again sin x. F of x plus 6 pi, it means sin of x plus 6 pi, again you get sin x, and so on. Here t has different values, 2 pi, 4 pi, 6 pi, and so on. Among these values, the smallest one is 2 pi. Therefore, period of the function f of x, is equals to sin x is 2 pi. Period of the function f of x is equals to sin x is 2 pi. Similarly, period of cos x is also 2 pi. Tan x, period of tan x is pi. So here we learn one important property of periods. One of the very important condition. Suppose f of x is a periodic function. F of x is a periodic function with period capital T. Then the period of the function f of ax is capital T by a. Remember this one. Suppose f of x is a periodic function. With period capital T. Then the period of the function f of ax. Is given by capital T by a. One of the important point to remember. Now we learn the Fourier series and Euler's formula. The Fourier series for the function f of x, the Fourier series for the function f of x in the interval, the Fourier series for the function f of x in the interval c less than or equals to x less than or equals to c plus 2 pi is given by f of x is equals to a naught by 2 plus summation n is equals to 1 to infinity a n cos nx plus bn sin nx. F of x is equals to a naught plus a naught by 2 plus summation n is equals to 1 to infinity a n cos nx plus bn sin nx, where this a n is equals to, a naught is equals to 1 by pi integral c to c plus 2 pi a n, integrals c to c plus 2 pi f of x dx. A naught is equals to 1 by pi integral c to c plus 2 pi f of x dx. And this a n is equals to 1 by pi integral c to c plus 2 pi integral c to c plus 2 pi f of x cos nx dx. And the term bn is given by 1 by pi integral 1 by pi integral c to c plus 2 pi f of x sin nx dx. These a naught, a1, an, bn are called here a naught, an, bn are called Euler's formula. Some author says that Euler's formulas. So I repeat this one. The Fourier series for the function f of x in the interval c less than or equals to x less than or equals to c plus 2 pi. Remember the interval c less than or equals to x less than or equals to c plus 2 pi. This is nothing but closed interval c to c plus 2 pi is given by f of x is equals to a naught by 2 plus summation n is equals to 1 to infinity a n cos nx plus bn sin nx, where this a naught is given by 1 by pi integral c to c plus 2 pi f of x dx, and a n is given by 1 by pi integral c to c plus 2 pi f of x cos nx dx. bn is given by 1 by pi integral c to c plus 2 pi f of x sin nx dx. You observe the difference, then it is very easy to remember. 1 by pi is common in 3 terms. Integral c to c plus 2 pi is also common in all the 3 terms. The difference is in the term a naught there is no cos nx or sin nx. In an we have cos nx. In bn we use sin nx. That's it. So remember the logic, then it is very easy and simple to remember. These a naught, an, bn are called Euler's formulas. We learn some additional cases. Case 1. What happens if c is equals to 0? If c is equals to 0, then the interval becomes, becomes 0 less than or equals to x less than or equals to 2 pi. In such a case, the Euler's formula becomes a naught is equals to 1 by pi integral 0 to 2 pi f of x dx. an is equals to 1 by pi integral 0 to 2 pi f of x cos nx dx. Cos nx dx. Bn is equals to 1 by pi integral 0 to 2 pi f of x sin nx dx. Sin nx dx. That's it. Suppose we use one more case also here. In this case, note point to our case 2. We observe one more case. If c is equals to minus 5, if c is equals to minus pi, then the interval becomes, if c is equals to minus pi, then the interval becomes, closed interval minus pi to pi. Closed interval minus pi to pi. That is minus pi less than or equals to x less than or equals to pi. In this case, the Euler's constant becomes a naught is equals to 1 by pi integral minus pi to pi f of x dx. An is equals to 1 by pi integral minus pi to pi f of x cos nx dx, and Bn is equals to 1 by pi integral minus pi to pi f of x sin nx dx. So you observe that this is the original Euler's formula. In the interval c less than or equals to x less than or equals to c plus 2 pi. So you observe the integral limits, that is the main difference. And if c is equals to 0, the same three formulas takes this form. I mean only the limits are changed 0 to 2 pi. And in c is equals to minus pi, again the limit becomes integral minus pi to plus pi. So this is the main difference in three cases. So we solve a problem to understand this formula. So the first problem, express f of x is equals to x minus pi as Fourier series, in the interval minus pi less than x less than pi. Minus pi less than x less than pi. Okay, let us solve this problem. They given that f of x is equals to x minus pi, and the interval is minus p less than x less than pi, not p, minus pi less than x less than pi. The Fourier series is given by the Fourier series is given by f of x is equals to a naught by 2 plus summation n is equals to 1 to infinity a n cos nx plus summation n is equals to 1 to infinity bn sin nx. Let it be equation number 1. Now we find one by one. The very first one, a naught is equals to 1 by pi integral minus pi to pi f of x dx. Because the interval is minus pi to pi, so we use the integral limits. Because the given interval is minus pi to pi, so we use integral limits from minus pi to plus pi. That's it. You remember that. So right, now substitute every term, which is equals to 1 by pi integral minus pi to pi. What is f of x? X minus pi dx. You remember one basic fact. Here, this x is odd. I mean, x is odd function. If x is odd function, integral minus pi to pi x dx becomes 0. So what you get only 1 by pi integral minus pi to pi minus pi dx. So which is equals to, and these pi's 2 get cancelled, minus integral minus pi to pi dx, minus integral dx is x. What is integral dx? X, limits from minus pi to plus pi. You get minus of pi plus pi, you get minus 2 pi, minus 2 pi. Therefore we conclude the value a naught is equals to minus 2 pi. A naught is equals to minus 2 pi. Now we go for an. An is equals to 1 by pi integral minus pi to pi f of x cos nx dx, f of x cos nx dx. Now substitute all the terms, which is equals to 1 by pi, which is equals to 1 by pi integral minus pi to pi, integral minus pi to pi. What is f of x? X minus pi, x minus pi, and cos nx dx, cos nx dx. You split the integration, 1 by pi, 1 by pi, 1 by pi integral minus pi to pi x cos nx dx minus pi integral minus pi to pi cos nx dx, cos nx dx. Here also again you observe that, x cos nx, x cos nx is odd function. X cos nx is odd function. Therefore integral minus pi to pi x cos nx dx is equals to 0. What it means? The first integral completely 0. The first integral completely 0. This integral becomes 0. This integral becomes 0. So we solve only second integral. So which is equals to 1 by pi, 1 by pi integral minus pi to pi, integral minus pi to pi. I mean there is minus pi. So 1 by pi into minus pi, integral minus pi to pi cos nx dx. So minus pi plus pi get cancelled, minus, and this cos nx is even function. So you can write this cos nx is even function. You can write minus 2 into integral 0 to pi cos nx dx. Integral cos nx dx, direct formula, minus 2 sin nx divided by n, limits 0 to pi. Limits 0 to pi. You observe that minus 2 by n sin n pi minus sin 0. Both are 0. Both are 0. Sin n pi is equals to 0. Sin n pi is equals to 0 for all n belongs to z. And sin 0 also equivalent to 0. So this term 0 and this term is also 0. The whole value becomes 0. This shows us an is equals to 0. An is equals to 0. Already we find the value of a naught. A naught is equals to minus 2 pi. Now an is equals to 0. Now it is remaining to find bn. Bn is equals to 1 by pi integral minus pi to plus pi f of x sin nx dx, which is equals to 1 by pi integral minus pi to pi f of x, x minus pi sin nx dx. Split the integral 1 by pi integral minus pi to pi x sin nx dx minus pi integral right outside pi sin nx dx, again you observe that this x sin nx is even function, this sin x is odd function. This is odd means this integral becomes 0 because from minus pi to plus pi you are integrating, the term completely becomes 0. So finally you get this is even function. So you can write like this, 1 by pi 2 into integral 0 to pi x sin nx dx. By applying integration by parts, or by applying integration by parts or Bernoulli's principle, integral uv dx is equals to u v1 minus u dash v2 u plus u double dash v3 minus and so on, where v1 means first integration, v2 means second integral of the v, and v3 means third integral of v, and u dash means first derivative, u double dash means second derivative, and so on. Now our problem also in the same way, which is equals to integral 0 to pi. I mean there is a constant 2 by pi also. This is uv dx, uv dx. So where u is equals to x, u is equals to x, v is equals to sin x, sin nx, sin nx. U dash is equals to 1, u double dash is equals to 0. v1 is equals to integral v, it is equals to integral sin nx dx, which is equals to minus 1 by n cos nx, and v2 is equals to minus 1 by n square sin nx. So now you apply that formula here by integration parts, you simply get 2 by pi 2 by pi 2 by pi x into cos nx by n. You get minus also there, minus cos nx by n minus sin nx divided by n square, and the limits are 0 to pi, So you observe that 2 by pi minus x cos nx minus x cos nx divided by n minus minus plus sin nx divided by n square, limits 0 to pi. We know that sin n pi is equals to 0 for all integers, and sin 0 is also equivalent to 0. So this condition implies as all the second term must be 0. We use only first term. So even first term, you observe that 2 by pi minus pi cos n pi divided by n. Replace that x by n, upper limit. The lower limit is 0. If you substitute the lower limit 0 here in x, that becomes 0. So finally we get only simply this one, pi pi get cancelled, minus 2 by n, and cos n pi is equals to minus 1 power n. So you get minus 1 power n. Though simply you can write 2 by n minus 1 power n plus 1. So what is bn? Finally you get bn is equals to 2 by n into minus 1 power n plus 1. So we have all three values. You observe that a naught is equals to minus pi, a naught is equals to minus pi, a naught is equals to minus 2 pi, a n is equals to 0, and bn we get 2 by n into minus 1 power n plus 1. By definition of Fourier series, you can write f of x is equals to a naught by 2 plus summation n is equals to 1 to infinity a n cos nx plus summation n is equals to 1 to infinity bn sin nx. So what is a naught? Minus 2 pi. A naught is equals to minus 2 pi, a naught by 2 minus pi. So you simply get here minus pi plus summation n is equals to 1 to infinity, that a n is 0, 0 into cos nx plus summation n is equals to 1 to infinity, that bn is equals to 2 by n minus 1 whole power n plus 1 sin nx. So the middle term completely becomes 0. This term completely becomes 0. You get minus pi plus 2 into summation n is equals to 1 to infinity minus 1 power n plus 1 divided by n sin nx. So in the left side we have f of x. What is f of x here? In our problem, what is f of x? X minus pi. X minus pi is equals to this one. x minus pi is equals to this one. So you can write x minus pi is equals to minus pi plus 2 into, if you expand the series, if you put n is equals to 1, if you put n is equals to 1, we get sin x. For n is equals to 1, we get sin x. Minus, for n is equals to 2, 1 by 2 sin 2x. This is for n is equals to 2. And for n is equals to 3, we get 1 by 3, 1 by 3 sin 3x. I think you can understand now. Minus 1 by 4 sin 4x plus and so on. This is the required Fourier series. This is the required Fourier series for the given function f of x is equals to x minus pi. X minus pi. That's it. Keep learning. Wish you all the best. In the next video, we'll learn one very important problem depends upon Fourier series.